Ciao ragazzi, benvenuti alla mia sessione. Purtroppo il mio italiano non è buono, continuerò quindi a parlare inglese. Grazie. So my session is about the optimization of a data workload with data management. This is with partitioning, and this is not the default or the basics about partitioning. I would expect that everybody of you know how partitioning works, what the general functions of partitioning is. I want to show you some projects I had with customers where we had very much success by partitioning tables. So yeah, if you want to replay the demos or you want to play around with partitioning and something like that, I have two databases. I do, because of the short time we have, on my demos with the customer orders databases. And if you want to have the slide decks and the demos, you can download it here. This is the third link in my presentation. My commercial is very easy. Just only one point. If you have any questions concerning this session or anything about SQL Server Engine, just drop me an email. This is the most important thing. The rest is only commercial, then we can go over it. So all these user cases described in this session are based on real world scenarios, but I have really simplified this for this session. It was way more difficult to figure out what the problems are, but I want to show you the solution by showing you, first of all, the generic problem, how you can measure the problem, and after we changed the workloads, I want to show you the results of how you can measure whether it was a good decision or not. So here is my first use case for partitioning. It's a high transactional production system. So basically, when I talk to customers about partitioning, many customers really think, well, we're talking about partitioning. Partitioning does mean that I have to deal with data warehouses, so lots of millions of rows or billions of rows, and I think that is the reason to use partitioning. But to be honest, this is just only 50% of a reason why I can use partitioning. Here, this is a customer from me who is working in a pharmaceutical company. They produce drugs on various production lines. So I take, just only here for this example, 16 machines. They have over 70 machines in their environment, and there they are producing the drugs. And the problem is that really every single drug must go through a quality check. And the quality check gets stored in the database of our SQL Server. And that was a big problem for them. So here is the demonstration. What I want to show you. We have, in this scenario, 16 machines. Every one of these 16 machines is producing in a very high transactional rate, lots of records. All this information will be sent to a web service, and this web service has lots of threads working, capturing the information, put them in the right format, and then pushing them into the SQL Server database. And the customer was complaining about one big problem. They saw nearby, let's say after 3-4 hours working, that on the web server, every queue was completely full and there was no possibility to get more data from each machine. And that results in a stop of a machine. And that needed to be solved. And we were looking first on, a consultant was coming from the producer of the machines for the implementation of the web service. They didn't find anything. So they all pointed to the SQL Server and said, well, yeah, that's not a problem. You have the wrong hardware for your SQL Server. They wanted to build a bigger server, more cores and all this kind of stuff. And yeah, then we came into the game. We were watching what happens on the SQL Server, and we found out that the big point is they can add as much CPUs as they want. The system cannot scale. So it is not a problem of the CPU, and it is truly not really a problem of the storage, but is a problem of the design of the database. And this database is coming from the vendor of the production environment here. So what they did was this one. And I think if you look to this, you will see, well, yeah, easy. That's, let's say 90% of my database are working this way. We have the data in one queue, or in the queues, and they grew because SQL Server could not save the data quickly enough. The problem was that we have detected so-called latch contention, which was a problem because the database design was not able to scale. And whenever in the evening, they had a look to the indexes, we saw that the indexes were really severely fragmented because of the machine ID were different with each process. Have a look here to this very simple table. We have a machine ID, and then we have a sequence, we have a date, and we have a column which is only for the payload. And the problem is here that the database had just only one file, and this was just only on one file group, the primary file group, and the bottleneck was not the writing to the file, because when we monitored the queue to the storage, we saw that there was not enough throughput which was coming through to the storage. So what we then wanted to do is this, what I want to demonstrate here. Here is my demo, the first demo. So the first thing what I do is I create a demo database. And here is my very simple table design. We have a machine ID for maximum small int. So we have 16 machine, and we have a timestamp in it, and then we have the payload with this only 1 kilobyte, which will be filled into with every single process. Then I create a clustered index on it, and experienced attendees here will immediately see, oh my goodness, the unique index here is not the best chosen index for this kind of workloads. Because when every single machine will write into the table, and every single machine has a different ID, we will have lots of fragmentation here, because it will get stored, or it gets stored by the machine ID and then by the date. But that is not the key point here. This is one of the reasons, by the way. Here is a very primitive store procedure. What I do here, this is only a wrapper. I say, I have a store procedure, and I hand over to this store procedure the machine ID that I can simulate 16 machines, and they just heavily insert data into the table here. So that's it. Store procedure is finished. And now, because I want to see what's going on in my SQL Server, and I have a few tools to do that. What I absolutely love is to work with extended events. Extended events are a great tool to monitor what's going on in your SQL Server. And what I wanted to see is this one. Do we have latch contention? And if, please record them if they take more than 1 millisecond. What I also want to record is the page splits, because page splits are very expensive due to two reasons. The first one is that your transaction log will grow, because a page split will consume, and if they, let's say, if they take half of the data page and put it into another data page, it consumes in total around about 16 kilobytes in the transaction log. It doesn't sound much, but if you think about it, let's say 100,000 transactions per minute goes over to the SQL Server, then it could be a little bit of, then the SQL Server could run into trouble. And the last one, what I want to measure is, do we have any lockings here? And therefore I have an X event prepared, and here it is. And I want to show you how it works. You see here, the first thing what I need to know is, I need to know the database ID, number 6, that is great. And then I switch over to the SQL command mode, because I need this variable here. And you see here that what my X event is collecting. The wait info for everything what takes more than 1 millisecond and happens in the database. Oh, what this here? 5, it's okay. What happens in the database with the ID number 6? This can go ahead. This is wrong, sorry. Okay, then I want to have the information about suspended latches. So when they will wait for more than 1 millisecond. And for me, one of the most interesting part here is to see when a page split occurs. And I promise you that will happen very, very often here. I store this information in a extended event file, and then I can run queries against this. So this is done. Now you can see here in the extended events session. So here it is. And you see here that I have this event file in it. So the demo can start now. And so go back to this. Here we are. And I clear my performance counters because that's an interesting thing too. There you can see if you compare the performance counters with the original system, compare it to the optimized system, you can see the benefits here. So I hope that all of you are aware of the RML utilities. RML utilities give you a great opportunity to simulate workloads with multiple processes. So here we are, and I run this here. Let me shortly explain what happens here is I have a batch file, and in this batch file, I now start 16 processes with O stress, and every single process will insert now 10,000 rows into my table. Let's see how long it will take. So the 16 processes are running, and by the way, my CPU here is heavily burning because of this GoToMeeting. I hope that I can show you at least a little bit of the benefit of partitioning here, but let me show you what happens here. Time for you to learn a little bit German. Datenträger does mean we're looking for the storage. And here is my SQL Server. And the first thing, what happens here is it will go up a little bit when it's finished. You see here that SQL Server is writing into just only one file here. It's the MDF. Here is my log file. And have a look to the throughput. You see that it writes with nearby 3 megabytes. This is not really much. I have an SSD here running, which can handle way more. And you see that SQL Server writes into my database file with approximately 2 megabytes. What is the problem here? Well, think about a supermarket, and now 16 guys are getting into the supermarket, and they all want to buy the things always at the same time. And this leads to extreme long queues at the cash desks. And this is the reason why we are not so fast. We are blocking each other because we all want to write into the table. And that means that we have lots of contention in the table. You see the, oh my goodness, here, 1 minute. But this 1 minute, to be honest, is just only because of the GoToMeeting. Normally, it would be finished in 30 to 38 seconds. I'm very sorry about this. But however, we need to wait till it's finished, but then we can analyze the workloads. But it's very interesting that you see also that because 16 machines are writing, they all have the same workload. They have different times to finish here. See this one, 1:26, and this came 4 seconds later. So while this is working, let me check what's going on in my SQL Server. I'm monitoring want to see my weight statistics here. And this is something what makes me a little bit nervous, because what I see is that my system is mostly waiting for write log, which is fine, by the way, for these kind of workloads. But look to this. We have here page ledgers. Page ledgers does mean that we have concurrent access to the same resource, shared logs, if we run a select on it, exclusive logs, and so on. And these are here. And the SO scheduler yield, by the way, here you see it with my system. This is a nightmare, an absolutely nightmare. This does mean that I wait in average 9 milliseconds to get to the CPU. But as I said, This is coming from the GoToMeeting. I'm sorry about this. Hope this is done now. Okay, it's running. This is live, this is demo. Okay, so let's see how many data we have here in our table. Oh, here, it's 160,000 rows in. Have a look to the page count, 22,000. Fine so far, but bang. My index is completely fragmented. So whenever we want to run analysis for every single machine, it will not fail. That's stupid, but 98% fragmentation just on this table. This is really a problem here. So I stop this now. Okay. Wow, 4 minutes. 4 minutes. This is amazing. 4 minutes. Let's see how we can do this better. So in the meantime, my extended event has recorded a few things, and let me see how many page splits we have. Before I run this query, I just want to mention that I want to have a look to so-called bad page splits. What is a bad, or what is the difference between a bad and a good page split? Page splits will always occur. I'm running a SQL 2019, which means that whenever a new extend gets allocated, which is directly near to the last page of my current insert, then I'm talking about a good page ledge. But if I insert a new record into a filled page, then the half of the page need to jump to the end of the index, and that means that there is a difference more than 7 data pages in between. And this is what I'm recording here, or what I'm analyzing here, and see the number of page splits we have. Stop. Let's go for this. So, see the number of page splits we have in the system, and keep in mind a page split is consuming time, CPU, and storage. So come on, just have a look. Yeah. CPU. Look to this. That's cool. 108%. Very cool. So here you see this, and we have recorded over 20,000 bad page splits. So nearby 25 every 25% of the data SQL Server needed to split or needed to move data to a new location, which is not directly in the next extent. And this is the point where I would say, well, this makes SQL Server or makes the workload slow. We look to the page ledge contention in the same way, and here we go. So I read from this file, and then I make the evaluation here. And what I want to see is the number of ledge, so the page type, ledge mode, and the count. How often did it happen? And look to this, how often we have here, we were waiting for exclusive logs, and the duration was over 1 second, just only for the simple workload. This is really long, absolutely long. On the index page, exactly the same, 2.7. And here we were looking for a shared log, and the average duration was 9 milliseconds. So for every single request of the 281, we had, in average, now around about 10 milliseconds to wait to acquire the lock on it. So this, you see that the system cannot scale here. Okay, so what did we do? The principle is, I think that the principle is very, very easy to understand. When we have 16 machines, so that's what we do here, we now work with partitioning, and we say every partition is dedicated for just only one machine. That's very easy. So it means for me that I need to have 16 partitions here. And the good thing with partitioning in this use case here is the machines they were using for the production of the drugs were different. So we had one, let's say, for headache pills, one for whatever. So there were different production lines. The good thing what you can do then as an architect, as a database architect, is you can scale your system. Let's say the machine number 2 has a very, very extreme workload. So then if you see contention on that file, double it or make 4 files just only for this partition here. And that gives you the opportunity to scale your system in a very fashion way. And this is what I want to do here. First thing, I empty my table. And then here, what I'm doing is I create for every single machine in a loop, I add a different file group, and every single file group gets just only 1 file. For the presentation, it is okay. So here we are. This is a statement. I printed it out. So alter date, the database, add a new file group, and then make a new file or add a new file to this file group. Next thing then is, as I said, I don't want to go into detail how partitioning works. I need to create my partition function, and what I'm doing is for every single machine, I create my own partition area here. So number 1, 2, and so on. And the third, this is the last step, is that I need to now need to connect my partition function with the physical schema, with the logical and the physical schema, and therefore I create a partition schema on it. Only important thing what I want to mention is, you see here that I have 16 machines, but I'm using 17 different file groups. The reason is very simple. Whenever you do a partitioning, so here you see that I'm taking a left one, does mean everything which is lower than 1 goes into this file group, and so on and so on. And here with the number 16, it does mean everything what is lower than 16 goes into this one. But what happens if accidentally someone is entering the number 17 or something like that? So everything which is greater than 16 goes into this one. Here we go. Finale. I drop my index, and now I recreate my index. And I do it again on the machine ID, but this time I'm creating my index on the partition scheme, and I say the machine ID controls to what partition the data needs to go. Here we are, done. So clear the wait stats. So then I stop my session because I need to delete the old recorded file here. So, because otherwise it will evaluate it again. And then I start my session again. And now I start the workload again. So here it goes. 16 sessions. And the first interesting thing is now, when I look to you see my CPU, this is truly amazing. It is faster than 100%. This is really cool. And here's the bad guy. So here I go into the disk and look to this. What SQL Server now is doing is very interesting. We are now writing, it goes up. It takes a little while. But now SQL Server can distribute the data way more easy to the different data files. And if I would have a better storage, it would definitely help here. And the good thing is, buy the CPU. Okay, so normally I would see here when I prepared these demos, you will see here up to 5 megabytes per each file group what SQL Server can write here. The reason why it is so slow is that it gets blocked by the CPU. Yeah. So, but yeah, here's my log file. But the good thing is that it gets evenly distributed over all files. So in the meantime, I want to see what SQL Server is waiting for. Here is my wait stats. And yes, the write log is definitely the number one. And this is what I want to see. But the good thing here is you don't see the latch contention anymore, because we don't have, because every single machine is now writing in its own partition. And whether we have the index now on the machine ID first, or on a date time, here in the machine ID, it is absolutely fine because now we have partitioned by the machine ID and nothing gets blocked here. The only thing what makes me a little bit nervous is this one here. So experienced DBAs definitely know what this means. The thread pool does mean that I'm running here 16 cores on a 4-core machine. And the problem is that the so-called threads, the worker threads, are out. Yeah, I have not too less, but the problem is they don't get back as fast as I want them to be back. And again, CPU problems here, but as I don't want to repeat it anymore, you know what the problem is. But the good thing is I'm mostly waiting here for a write lock, and the average wait time is 4 milliseconds. This is absolutely brilliant. This is what I want to have. I want to see it less than 1 millisecond, but it's okay here with the circumstances. And the reason is very easy, because now we can write more data at the same time. And normally my log file would have a way better throughput as it had before. Because before the first demo, it was blocked by the latch contention. Oh, it's done. Oh, fine. Let's see how long it was taken. Yeah, not 4 minutes. It was 1 minute. By the way, it's always way too long, 1 minute too long. But this is okay for this circumstances here. So what we have done with this customer, and that was really an amazing thing, we had increased the throughput by 3 to 15%. It was depending on the different machines. And that was only because we have partitioned the table, and for every single machine, we were writing in a dedicated file. And so I'm working with this customer anymore. What we're doing now is that we think about, if we see that we have machines which could load faster, then we are now we have the situation, because it's a virtual machine, that we add another drive, another storage area, and then we put these files on a dedicated drive, and that speeds up too. So we have no more page latch contention. We have a better throughput, and now, let's see this. This is really amazing. I want to see the page splits here. So the bad page splits, exactly the same query. And if you look to this, we had 20,000 the first time, but this time we should see just only, let's say 200 maybe here. Oh, great. It's just one bad page split, one. And this is really a cool thing. And if I look for the latches, so did we wait for page latches? It might happen. For example, if your table is a heap, then we could have PFS latch contention. But here you see, instead of hundreds of thousands, we just only have, yeah, that's what I was expecting for the IAM page. It's fine. But look to the data pages. Yeah. And to be honest, this is peanuts. This is nothing. So the system can definitely scale way better as it was doing before. And that was a really great success here for this customer. He was really happy about it. And we could see that no more waits or no more requests have been waiting in the queue. Here is my my distribution of data. Everyone got 1,000, but look to the fragmentation. But this is no magic. This was absolutely clear for everybody of you who is experienced. See Hugo here, I see Itzik here, I see Erland here. So this was absolutely clear, because the clustered index was on the machine ID and you had it on the second key on the datetime. And that was easy, that we don't have any more page splits or have heavy fragmentation in it. But that was two good points with one solution. So this was the first thing, the first demo, where I wanted to show you how good it is if you are working with partitioning. So keep in mind that partitioning will not always be for, is not designed primarily for data warehouses. It could definitely speed up your OLTP workloads in the same way if you have the situation here. The second one was really interesting, but but I think that my CPU will kill me now, but it's okay, go for it. Here comes the second, well, stop, where it is. Here, sorry, so. Use cases, number 2, the data warehouse concept. So that is a thing from one of the biggest retail company here in Germany. It's under the top 3. And what they are doing is very interesting. So every night at 10 p.m. when the stores close, they get the process inside the supermarkets which download all the information from the cash registers into a data warehouse. That is for one important reason. The company needs to know what they want to create reliable plans for supplying the supermarkets. So let's say if you think you just only need 5 buckets of bread, but suddenly 1,000 people are coming there, that is not a good choice. So that is the reason why they want to get the data as fast as possible in their data warehouse. This is how it works. You see here that we have different cash desks in different stores. So every single block here, what you see here on the left side is a different store, and the C1, I didn't number it, but these are the cash desks. So what will they do? They collect the data, then they're pushing it over an FTP server into the SQL server, into the database server. So, and let me show you, I hope that my CPU will hold this, here with the demo number 20. I again create my demo database. So what I'm doing then in my demo database, I create a schema staging. I need this here because I want to preload it. And then I have my table cache analysis, and I have exactly the same table in my staging area. That's the key point here. So I generate here a few data with 9 million rows. Takes a while, okay. And then I create a clustered index on the staging here. Doesn't make sense really, but it's okay so far. Then when the data comes in, I create a clustered index on the warehouse ID and the cash desk ID. Come on. This is unpredictable. I'm really astonished how much CPU this GoToMeeting is using here. Wow. Hope it's done. Come on. Okay, good. So create the clustered index. Here we are, and this is then the amount of data. I skip this. It's okay. That will show you only per warehouse, per cash desk, how many records we have in the table. So, and then I'm doing this one. I create the original table where the cache analysis will go into. Come on. You got it. Come on. I'm so sorry about this, guys. Really. Normally it takes only a few seconds. Oh, it's done. Okay, here is my table, the cache analysis. So what I'm doing is when I load the information, I will store that just only in a table called data warehouse load log, that I can see the difference in time, how long it was taking. Easy, go, that goes. And here is my stored procedure, which do the import from the staging into the analysis table. And this is a very simple thing. I hand over the warehouse ID, and just only here for the workload, I have a counter which goes through every single cache desk, only to demonstrate a little bit of workload. So, and what the system then is doing, here you see the number of cache desks, then we go through it, and here we push the data from one cache desk into the analysis table, and then we go to the next one, and so on. This is my workload. Drop the counters. Here we go. And again, for this one here, I have a batch file, the workload number 2, and I start this one, and that opens then for every single warehouse. This process is analyzing how many cache desks they have, and then we push the data into the table. The problem we have here in this one, whether it takes long or not, it's okay. The problem we have here is a completely different one as we had with the machines, with the production of the drugs. The problem here is that we are suffering from log escalation. And the reason for that is very easy to understand, because now SQL Server is pushing more than these magic barrier of 5,000 rows into the table per each cache desk. And what will happen then? If we have lots of workloads here, what the problem here is that every process wants to insert the data into the into this one table. Well, and I think that you all know what happens then. If we reach these 5,000 logs, then SQL Server will automatically start log escalation, and the log escalation in a non-partitioned table is always the table itself. So what does this mean? Process number 1 is coming, pushing 10,000 rows into it. Say, stop, guys, you have to wait. I'm locking the table, I'm inserting my data, and when it's finished, then the next one is coming. And you can, I think you can understand what happens at that time when 16 or 20 or 100 processes are running at the same time. Let me see whether it's finished. Oh yeah, here you see it took 43 seconds for around about 10, 15 cache desks. 43, and then it's going up 1 and 6, 1 and 10, and so on. And let's see for what we did, for what we were waiting. And again, this one, the process looks completely different. Look where the write block is. The write block weights are not the key point here. This is something I want to see. The main wait type is the page ledge, the exclusive page ledge. And that's because lots of other processes were waiting in the background for getting access to the table. This is the problem in this scenario here. So now let's see what they recorded here. And here you see that this is my warehouse. And you see here how long it was taking, 40 milliseconds, 41, 1 minute, and it's going longer and longer. And the question, I can promise you, really, you have to believe me, for every warehouse, I have nearby evenly the same distribution of data. But you see that it's 40 seconds and then this 120 seconds, this is a nightmare. Yeah, it's three times longer. And the reason is very easy. While this one was writing, this one was waiting, this one was waiting, this one was waiting, and all this time is counting to the process time. So what can we do then here? Well, we can do exactly the same as we were doing with the first workload. I truncate my table. So, and I want to show you the problem again. I start just only for this warehouse number 1, the import. When it's done, I want to show you the lockings in this, and then you can see definitely what's going on. You see here that SQL Server has a exclusive lock on the table. That's the problem. And believe me, that happens very, very, very often. I see it very often from data warehouse architects when they load, or the ETL processes, when they design the ETL processes, that they do not consider locking and blocking. So now I again create my database or partition my table. Go for it. So you see here, we have different partitions. Then I check this, and you see here, these are my, for every single warehouse, its own partition. Create the partition function and my schema. Brilliant, okay. And then I create a clustered index on it, on the warehouse and the cache desk. And at the end, when the design is finished, it looks like this. So here you see that this table has this index partition. Partition number 1 is see in which file group it goes and how much rows currently in. The table is empty. It's okay so far. So we go again for the weight stats. And now I run this process again. So starting. Now I want to see, yeah, I know what the problem is. I'm a dip. The problem is here that we have created a partitioning. We have exactly the same problem as before. So what we will see here, hope it will work, yeah. You see here that we are waiting, that's page ILH, so it means we're waiting for storage. But what I'm expecting here is that we will have an exclusive lock on the table itself. The performance will not be better as it was before. The problem here is that also I have created a partitioning environment here. The system cannot scale. The system cannot scale for one simple reason. I stop this here, it's okay. Come on, get finished. Okay, so the problem here is that I don't understand why Microsoft does not make it a default. That means when I create when I create partitioning for a table and I create an index for it, or when I partition my table, I'm really wondering why the SQL Server or Microsoft not automatically, come on here, set the lock escalation to automatic, because that is a problem. If you don't set this, when you have partitioned tables and you don't use the lock escalation, set the lock escalation to automatic, what will happen at in that moment? Well, in that moment, SQL Server will have the same behavior for the locking as when it is a simple table. So that does mean when one process is pushing the data into the table, and we are jumping over this border 5,000 rows, approximately 5,000 rows, it almost depends on the width of the record and so on, then SQL Server will automatically lock the whole table. So whenever you're working with partitioning in a data warehouse, that's important, in a data warehouse, and you have ETL processes which are pushing lots of data into the table, more than 5,000, that the lock escalation jumps in, make sure that you set the table's lock escalation to automatic. So I do this here, truncate the table, and now I show it only here in one single process. I only insert the data from one warehouse. So the time is not so important here, but the locks. So what we can see here, come on. Okay, where is the object? Searching. One moment, 11,000, yeah, that is okay. So we have key locks here. That is not the way I have expected it. Maybe too less, no, that's okay. Just let me have a look. The point here is that SQL Server won't lock the whole table, but normally I would have expected here that I see an heap or beat tree lock on the partition only. So yeah, this is the god of demos, which doesn't allow me to show this here, unfortunately. So we'll roll back the transaction. My goodness. Sorry. Okay, good. Okay, so this is the second way how you can deal with partitioning. And I have 10 more minutes. Let me show you one more thing. So I can drop this one here. This is more for the DBAs. I think in modern times, as it is now, we are not, I would say, so the average size of a, that I skipped this here, so management of the big databases. So in modern times, our databases are not only 100 megs or 1 gig or 100 gigs in size. I have one customer here in Germany, and we are working with them together in one database which has a size of 14 terabytes. And the problem is if you have SLAs. So if you have SLAs which say you need to, or you should restore your database or the active portion of your data within 30 minutes or 60 minutes, to be honest, a 14 terabyte database cannot be restored in 14 minutes. So, and here comes, here the SLA determines the downtime for a hot data within 60 minutes. And what can you do? How can you achieve this? Well, it's called piecemeal restore. What you can do is you can restore file groups. And this is something where partitioning helps you a lot. So let me do this here. So I create my demo database. Go. Then I push 3 million rows into a new table. The database has just only one file. Here, then I create again my partition function. This is based on the year of the order. So I create my file groups. So, and then I combine the function with the partition schema, which combines the function with the physical layout. And here I create a clustered index on it, on the ID, on the order date. So, and now I add different file groups. What this here? One moment. Yeah, this is okay. Yeah, this is okay. This is a little bit, so I don't like to when I create the partition function, here it is, it's okay, it's fine. So it's done, perfect. So hope this was done. And now what I'm doing here is the following. And this is something what you will see very often in big databases. You have active parts of your data and you have passive, or you have old, cold data. And what you basically would do normally is, but what I'm doing, what I recommend to my customers is put the old data in a separate partition, then make an update on the statistics, rebuild the indexes, and mark it read only. And that's what I'm doing here. Let me see, did I do this? Yeah, okay. So what I'm doing now is I mark all of my data from 2000 up to 2018 as read only. Perfect. So, and now you see how my data, my file groups are set. The 2000 read only, blah, blah, blah. And here my last one, the 2018 and the 2019, these are my active parts. So I run a backup of it. I run a backup of it. Yay, okay. Good. And now comes the big crash. So one morning, they all want to work, but the problem is database is gone. And what you then can do is the following. And that's perfect with file groups, with partition file groups. And that's the reason why I've used partitioning here. What I'm doing now is I say the database is running in simple recovery model, by the way. So what I'm doing here is I take from my last backup, I say to SQL Server, please restore my demo database, but only the read-write file groups. So only the last two file groups from 2018 and from 2019. So go for it. Yeah. And now when I look to the files, you see this. And you see here that now, but oh, sorry, I've forgotten from one thing. You need to have Enterprise Edition for this, but I think that you know this. Okay, so here is my demo database, and here are my old database, old file groups. They say, well, recovery pending, that means they are not online now, but the 2018 and 2019, they are online. And this is something where you as a DBA now can perfectly say, brilliant, now I go to the kitchen and grab a coffee, because now you can completely relax, because your company can work with the data. You can run select on every 2018, 2019 rows, no problem. But if you run this kind of query, it's clear that it will fail, because it's not, the ID, this is, by the way, yeah, the customer ID is not the partition key. So the customer ID, SQL Server needs to go over all partitions. The 2019 and 18 is just only online, the rest not. But then you can go immediately say, well, wait, hang on, we now restore every single read-only file group for you. And here you see that is number 2000, 2001. And in the meantime, you can extreme relax and see how it, and that's a cool thing. So when you see that one is finished, the 2000, for example, you can drop a note, say, well, if you want, you can now run a query again, 2000 orders, because when they are online, everything is okay. Yeah. And this is one of the things I absolutely appreciate, especially when I'm a DBA in a company which is dealing with big databases. So the database with this one customer I have here with the 14 terabytes, they have exactly this problem. That was the reason why they asked me how they could handle this, and we recommended it. We made it in the UAT environment, so in the test environment. They were so happy about it, because now they handle it more relaxed, because yeah, they know how to deal with it, bring the hot data online, and then relax. And for you now, it is time to relax too. The session is over. I hope you enjoyed it, and now I'm open for questions if you have any questions. Oh, there is one, two. All in current data changes. Marguerite. So let me, okay. Here's the first question. If you mark a file group, this is from Joseph. Thank you, Joseph. If you mark a file group as read only, it can't be part of an, yeah, always on. That's true. Absolutely, yeah, that's true. Yeah, but is a data warehouse in an availability group? I would say no, but it's true. Yeah. So cannot be if you have an always on availability group. Danielle, grazie. Partitioning can be used to separate old and current data based on dates that changes during time. Yes, sure. So if you, let's say you have a partition key here, in my case, if I have the partition key on the date, here I did this here on the date, this moment, here it is. So let's say you have one order which is coming from 2019, and you change the date to 2018, it goes automatically in this partition, it moves automatically over to the other partition, because the partition function determines to what schema, to what partition area the record belongs to. In this case here, I had a range left, which means this is the maximum value for the partition, number one. So everything which is lower than the 31st of December 2000 goes automatically in the first partition file group in this case, because I was working with file groups, and that will automatically move over if you change the dates. Any more questions?
Okay.
We are really in time, yeah. So
okay, it's perfect in time.
yeah, so then I would say, let me try it in Italian language. Grazie for listening. E alla prossima anno. Is that correct?
Yeah, yes, it's correct. Great. Thank you so much for your session.
Yeah, I'm so sorry that I didn't know. I need to admit, I didn't know that the GoToMeeting has such a big impact on the CPU power of my small tiny laptop. I'm really sorry for that.
No, don't worry. There is another question.
Yes.
Tommaso.
Do any of these queries work on Azure SQL 2? I would say, yeah, 50-50. In Azure, you are not allowed to determine for the file groups. You can define file groups, you can add files, but the problem is that you cannot define the drive to where it goes to. But you can use partitioning in an Azure database. Yeah. But that's working. In a managed instance, definitely, because we are doing that with another customer currently. As I said, the only problem is you cannot define the file location for the database files.